Okay, so welcome everybody. Today it's about data cleaning and exploration. Just to give you the high-level picture again, we are here in this first phase, analyze data, and we're looking at the two sub-phases, explore and profile data, as well as clean data from a practical point of view. So I will present 1, 2, 3 data sets, and we will explore the data sets in Python a little bit and clean the data if necessary, just to show you what it is like in practice to work with a real data set and what the problems are, and in particular in terms of Python, the things you may want to do and you may want to learn about that, because it's like everyday business. Yeah, I have an example here. I'm using the IMDb data set. IMDb is this website where information about movies is collected. Do you know IMDb? Yeah, all series, movies, whatever you can see on Netflix, Amazon Prime, in the movies, on TV. That's a big database, and that collects all the data about the actors and the movies as such. Did I change glasses already? No, I didn't. I want to change glasses today. Okay. That's my laptop. Now I can see my laptop. Okay, so what we will do, I will use a couple of libraries, so that's predefined functions, if you want, if you wish, that were provided by everyone who wants. Anyone can provide a library, a Python library that you can then import, and then it's a matter of maybe you have to install it first. So in Vagrant, hopefully everything is installed. Sometimes if a library is not installed, what you have to do typically is you have to write something like pip install or something like that. Yeah? So maybe, I think we don't have to go into that now. But all these libraries now are installed in my installation. And basically, those are large collections of functions that I then call. So I don't have to reinvent the wheel. So for Python, one strong thing about Python, in particular in the context of data science and artificial intelligence, there's an insane amount of libraries. It's insane what you find out there. So typically, for most of the problems you will run into, there's a library helping you. Yeah? So the first thing when you have a problem is not you try to reinvent the goal, but try to find, hey, is there a library that already solves that? And that's sometimes a bit difficult, but often you quickly find the library. And those libraries were provided by different people, and they have different quality. And typically, it's like that only the best libraries get very popular. That is the case. But for one library in data science, that's not the case. And, that is a library that's not terrific, but it's super popular, and that's called Pandas. From an academic point of view, it's not good, but it's used all over the place. And I will show it today as well. How it is used, some of the important things you can do with that. Just for you to keep in mind, there are better ways of doing that, and how that works you will learn in the database class in the 4th semester, summer term, big data engineering. They will show you how that is done for real, not with Pandas. However, Pandas is used in many, many places. Many other libraries have interfaces to Pandas. It's okay for certain scenarios, but how we call it, the API, the programming interface, the set of functions they offer is weird sometimes. You will see. Anyway, so I load those libraries, shift return as usual, and here I show the data set. So this exclamation mark basically means, okay, now what follows is a shell command. So this is executed on the underlying shell that I'm using, and that is the data set. So here's 1. -5 means I'm showing 5 rows only, and you see, so that is 1 row. That is attribute names. It's basically the schema, as we call it. Yeah? That's only the first row telling me, whatever follows in rows, it has the following schema. So this is the first data row. This means the first attribute value here is a rank. Then there's the title of a movie. That's this one. Then there's a genre. That's actually a list of genres here. So action, adventure, sci-fi. Then there's a lengthy description, a short summary of what's going on in the movie, and so forth and so forth. Yeah? So only the first is this header line, as it is also called, and then there's a couple of entries for the different movies. I think this data set has about 1,000 rows or something like that. Yeah, so we don't want to work with that on the Unix level. We want to work with that in Python. And what I do is I read it into a pandas data frame. So that's more or less a table style data structure. So that's all you have to do. Actually, when you call this read underscore CSV method on a data frame, it already understands that this has a header row, so that is respected already. Yeah? So what you import the library like that, import pandas as PD, and what is returned here is a data frame. If I display it, here that's the type. You can always write type around a variable and then you get the type. So pandas core.frame.data frame. And if I display it, it looks as follows. Yeah, so you have here already the attribute names in the header, and then you have the rows. You see this is the first, if you go back at the data, so here the first attribute value was this number, the rank, whatever that means. Here you see in the data frame there's an additional number, that's the internal numbering of those rows being inserted by the pandas library. Yeah? Just for you to know, there's no attribute name on top of that, it's just an internal numbering. But other than that, it's basically what you expected, yeah, and some interaction here with the mouse and stuff you can do. Nice visualization of that table. You see ... meaning, okay, I omitted, some rows were omitted in the display. So here you see it's basically the first 5 rows, and then everything in the middle omitted, and then the last 5 rows. And then shows me also the shape, as we call it, of such a data frame. The shape means that dimensionality. So this thing is 2-dimensional, obviously. So 1 dimension is the number of columns, that's 12, the number of attributes, 12. And the number of rows is 1,000, as I said, 1,000 movies. So that is the entire thing here is a shape. 1,000 rows times 12 columns is the dimensionality of this frame, 2-dimensional data structure. Yeah, okay, so once we are there, we loaded the data somehow into a pandas data frame. What can we do? Maybe I can close this now here. What can we do? Yeah, again, I can display the shape. That's what was displayed here already. I can show the head. So the head only displays the first 5 rows in that case. I can print out some information. Yeah, so here for each data column, I get an information, okay, what's the name of the column? How many of those values are non-null? Null, as said before, I'm sure, I think it was in this lecture. Null means, in database language, or in data language, null means not assigned. And there's no value assigned to this attribute value. Yeah? 1,000 non-null means, so for each and every row, the rank attribute value is defined. There's something there. There's some string, a number, whatever. There's something in the data. Yeah? It's not that there's nothing, there is something. A difference here for revenue, for instance, there are some rows where there's no entry whatsoever. And I don't mean an empty entry, I mean no entry. Yeah? That means, so null for us is a placeholder for saying there's no attribute value assigned. Yeah, you get some memory usage, so that's pretty much peanuts, type information as detected by pandas and so forth. Yeah, then you can only show the data types. There are tons of functions. I'm just showing you some of them. So describe is relatively useful. That gives you statistical information, like the minimum value, the maximum value. Why would minimum or maximum value be interesting for anything here? Any idea? How could you, at this point, exploit the fact that you get the minimum or maximum value of something? Some idea? I made some statistics. Sounds scientific. He's doing statistics. Yeah, cool. Yeah, hey. But why would that be why would it be useful for this case? If I print the minimum and maximum of something here. Think about data cleaning. Yeah, we want to clean the data. So cleaning means all the data is dirty. Well, what does dirty mean? Or there's some crap in the data? Yeah.
For example, if we find some garbage like that, one of the movies has a runtime of 1 minute and is a short film, and we actually only want to do our data science on actual cinema films, an hour more, we would see that here.
That's true. So there could be movies that are only like 1 minute. Actually, there are short movies that are like that. There are short movies that have a couple of seconds. that wouldn't be necessarily a problem or an error. That could actually be the real entry. Yeah, so that would.
Yeah, but maybe we done one.
Yeah, you're already thinking about the second step. The question is, what is the kind of analysis I want to do with the data eventually? We didn't talk about that. Here is only the question: can I trust the data? Yeah, the values found in those files, do they make sense or not? Yeah, and I'm saying. In practice, it could be. I mean, there's a short movie that's just a couple of seconds. Why not? Then that would be the minimum runtime here. Yeah? So what do we have as minimum here? I have to change this one. The minimum runtime here is 66 minutes, right? Yeah, minutes. Yeah. So it's like at least medium long movies. Yeah, but there's another very obvious thing you would see in something like that. Some other idea. Yeah, look at the different attribute values and think about what could happen. It doesn't happen here, but it could happen. We've seen that actually in some data set from university. When you think about year, for instance, what might happen? What if you had an entry like year 2220? So the database is about productions that already happened. That wouldn't make any sense, right? Yeah, what if the movie was from 1830? Doesn't make any sense. Movie technology wasn't even invented by then. Yeah, so that would be obviously an error. Yeah, so we had similar experience with, we once looked at the university system, which collects all the information about lectures and stuff. Yeah, and there was a lecture, database systems. I give that lecture regularly. And it was given in 2030. Yeah, and actually they gave some grades for that, for some students. Yeah? I'm not sure whether they were enrolled already. Maybe they will still enroll later on, but they already have a grade for the lecture, recorded in the system, all that stuff, right? Yeah. So that's the common sense. Thinking about minimum, maximum doesn't make any sense. Would that correspond to what I would expect, what these attributes actually mean? Yeah? So, revenue could be another one. Yeah? If the revenue is 0, I believe that. So that happens here, revenue is 0. But if the revenue is whatever, $2 trillion, no movie ever made so much money, right? Yeah? So those are outliers, extreme outliers you could look for already at this point in time. Okay, yeah, now let's look at what we can do as this is more about exploring for the moment, not so much about cleaning the data. So what I'm doing here is, for this notation, I'm projecting to certain, I'm not sure whether you had that in Mars already. So basically, I'm saying I don't want to see the entire data frame. I only want to see 2 of those attributes, namely description and rank. Yeah? So it's the same thing as before. However, some of the attributes, some of the columns were thrown away. So Pandas always keeps this internal counter thing, so that's like a third column, but like the 2 official columns, description and rank, are shown here. Yeah? So that's just what I can do here, and with that you reduce the amount of information, maybe it gets more useful in exploring that. Again, recall I write type in front of any variable here, and I get the type information. So you see, it's still a Pandas data frame, okay? So here I do a similar thing, but however, I only project to a single attribute. Yeah, so if I write that, so if I remove the type information here, what do I get? Boom, description, yeah, plus this internal counter. So what type? If I now enter shift return, what is the type being returned? What do you think? No, but a good guess. Yeah?
Probably going to be some internal object of the library.
Yeah, another guess? Yeah, you know what I'm alluding to, but I'm tricking you into something. You're right for the second. Pandas series. What did I miss? Also the type. Pandas data frame. What is the difference? This is single attribute. So what I pass here to the square brackets is a single attribute. What I pass here is a list of attributes. This is completely stupid. Sorry. This is completely stupid. Yeah? So what this means is what I pass as a parameter determines the return type. This is not how functions should be implemented. The function should have a fixed type. So in the real, when you learn databases, you will see whatever you do, whatever you get, you always get returned the same type, namely a relation or a table, if you want to call it. But here it's very weird, and that may be confusing. That's why I'm showing it here. Depending on what you want to do, you use this list notation, then you get a data frame, but sometimes you get, if you only specify a single attribute, you get a series. So basically, what that means is a data frame internally contains a list of series. Each column is internally represented by such a series, and that is what's being returned here. Yeah, that can be very confusing in Pandas. This sharp learning curve ahead. Okay, now what I want to do is I want to do a so-called word cloud. That's a fun thing that can be used for visualizing things. And what I do is I take this description column, so the summaries of the movies. So here write down the types. You can always return a tuple here, that's fine. Yeah, I do that. It doesn't have to be a single value. I write, okay, I want to have the type of the descriptions and I want to have the length of the descriptions. So the type is a series and the length is 1,000 entries, obviously. Yeah, here do a count. Count means again, count only the ones that are not null, same as before. Why did I do all this stuff? Whatever. So that's the leftover, sorry, that can be removed. And now what I do is I take all the text from the different entries. Yeah? So basically you have a series with 1,000 entries, with 1,000 values, and now I concatenate all of these values into a single string. I want to have a single string with all of that text, yeah? Not 1,000 different descriptions, but one large text chunk, yeah, where all the descriptions from the 1,000 different movies are concatenated into one string, a single string. And that can be done in Python with a command that's called join. Yeah. That's a bit weird and not, I think some other programming languages picked it up. I don't want to translate that. Okay. Picked it up, but basically how you read that is, how do I read that? So I have items, these items from that column, yeah, that basically returns me a so-called iterable. And then I use a map function. I think Joris told you about map, right? Yeah, told you about map. So basically what that does is the map function takes an input item and applies a function on it. So if the input item is x, this function will return the string of that x for each and every value. So if you have basically this items iterable returns the 1,000 descriptions from the movies, and for each of those descriptions there will be one function call to this function, a lambda function, an anonymous function, you could also call it, yeah, and it will take that description text and return it as a string. So this is a casting it to a string, and make sure whatever's being returned by Pandas, it will return it as a string. So, and then this join method, what it does is, it concatenates the different strings to a single string. And in between those individual strings that are concatenated, this is a glue in front. So it glues the strings together with a white space. It just makes a white space. So the result is first value, white space, second value, white space, third value, and so forth. Yeah, and that gives me that string. So if I execute that, I get a string that has like 173 kilobytes in length. Well, 100 length is the number of characters. Okay, if the character is UTF, it could be longer than that, but that's the number of characters. Yeah, and now I can use the so-called word cloud. Maybe I show it first, and then you see what that actually does. So the word cloud now gets this text as an input, and for each word in the input, it makes a count. It counts how often does a word life occur, the word friend, find, young, new, and so forth. And it visualizes the text by making words that occur more often bigger. So this means life occurs super often in the description. Find occurs very often in the description. Young, middle, there's crime a little bit here in the corner, forever is here, and so forth. So you get an idea how often these words occur. So it's a very quick and dirty visualization for text telling you which words are important in that text. Yeah? What's really important in movies. If you think about it, it makes a lot of sense. Yeah? Movies are about life, the world, finding, it's always a search for something. Family, love is astoundingly small here. Yeah? But okay, there are also horror movies and crime and stuff. Yeah? So it's not only love movies, it makes sense. There's story, yeah? There's a turn in the movies. Yeah? Woman, there should be men somewhere. Daughter, earth, wife. Makes sense, yeah, if you think about it. Yeah? And that's a relatively easy way of visualizing textual data, or get an idea what the important terms in these things are. Okay, so now let's work a little bit with this IMDb pandas data frame. And the first thing here we do here in this cell is we rename some of the columns. So one of the columns is called revenue, white space, in bracket, millions. Yeah, if you go up again, we see it. Can I do up again? Where is it? Oh, maybe I do it better. The mouse. Here it is. Yeah? That's this column. And that's sometimes a bit awkward to handle these column names that have white spaces. It still works, yeah, but I don't like it, so I want to rename it and basically replace the white space by an underscore. That is what I'm doing here with this command. Now I also want to break down I want to understand, okay, there are all these movies and they have a genre assigned. What are the most popular genres in those movies? So let's do that. And then I get something like that. So here you see already a problem. So the genre column actually does not necessarily contain a single genre. So some entries have that. There's only drama, but some have a list of genres. So that's very hard to analyze. Yeah?
Still about the word cloud thing, does it filter out words you wouldn't want to see there, like a, and the?
Yeah, those words are called stop words. Yeah, and then that's basically what this line is doing. That's a very good remark. Yeah, so whenever you work with text and you want to analyze text, there are so-called stop words that don't help, like the, yeah, all these stuff that occurs all over the place and doesn't give you any information. So those are called stop words. Also in search engines on Google, the Google search index will remove that stuff. Following textbook knowledge, I don't know what Google does internally, but following textbook knowledge, it would do that because, I mean, basically, like the term the in English would occur like everywhere in every text here, so it doesn't make sense to build an index entry on that. So. Yeah? Okay. So, what do we do here? Willkommen bei iPod Pro. Nee. So, where was I? Right, so the problem is the genres here contain these lists. Yeah? I can show you again an example here. We had it already. Yeah? So the genre is not a single genre. It's action, adventure, sci-fi for this movie, and so forth, and so forth, and so forth. Yeah? So that's hard to analyze to really understand what the genre is about. So we have to do something about that. So one thing is we want to split those genres. So basically, the first thing I will now do is to, I have the right glasses on, it's still not in focus. Okay, to find out which genres exist anyway. Yeah? That's what I'm doing here. So basically, I keep a set of the unique genres. I loop over all of the rows in that genre column from the IMDb pandas data frame, and then I update the set accordingly. This update method allows you to pass a list of values, in this case, a list of strings. Yeah? So what I do here is I call whatever I read from that genre column, in this particular case, I split it using this separator. Yeah? So what I get here, again, is a list of genres separated by a comma operation. You see it here. Yeah? So what the split function does, it splits, maybe I can show it, that's really, whatever, if you do like, blah, 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 and you say, comma, And assume you have an entry like this. Okay, and now if you do a split on that string, this is what you get. A list of the entries where whenever, so basically it's an algorithm going through the data from the left to the right, whenever it encounters this comma, it will split it. Of course, if I change that to anything else, it will, there's no small a, it's case sensitive. Yeah, that's how it is done. The character itself is not taken to the list being created. You see it here. Yeah? So if I use a comma, which is part of the original string, the comma is removed. The comma is just to separate the different entries. It's also the comma accidentally, to separate the entries in the list, but assume you see it here. Yeah? If I have a semicolon here, for instance, as part of the string, and now I split by semicolon, you will see it's the same entry here. Yeah? So one entry action, second entry adventure, third entry sci-fi. The comma is just to separate the different entries from a list. Yeah, so that's how the split operation works. And I do that here in a loop. I do it for each and every value, and then I insert all the genres I find into that unique genre set, and then finally I sort the set, and as this is the last entry in the cell, it's being sent to the output. Yeah, that's basically what happens. So I know those are the genres that occur in the genre column. Yeah? So far so good? Okay. So, but we are here, and now the question is, how do I get from a representation where I have the columns, the genres individually, where this is the start. Yeah? So what I can do is something like that. I could say, what we call a bit list. This is done here. Maybe I show what happens here. So this operation is a function testing whether the attribute value of genre contains this substring. Okay, this is done for each and every entry in this column. So it sounds as if this were a function call on a single string, but this is actually applied on the entire column, an operation on the entire series. Yeah? And what is returned is a series again where the entries are either true or false. Yeah? So basically you could simulate the same thing with a loop. Yeah? So for each and every, as done here basically, yeah? So for each and every entry in that column, I check whether that entry contains a string action. If that is the case, true is returned. If it's not the case, false is returned. Yeah? So basically, and this result is a data structure we call a bit list. Yeah, because with a single bit, you can represent whether it's true or false. 0 meaning false, 1 meaning true. Yeah, so I get a long bit list of 1,000 entries telling me whether the action string is contained. Yeah? Right, and now what I can do in pandas is that I call the original pandas data frame filtered by that bit list. So this is a bit list I computed here. Now I use it as the input in the square brackets. And then I get an error because I wrote S here. So, boom. Yeah. Was mache ich denn? Yeah, well, good. Yeah. Thanks. Yeah, now I only get those movies where there's this action string contained. And you see when you go through the data, action, 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 action. Yeah? I only show the head, which means the first 5 of those entries. If I remove that, I get all of them. And you see, it's 303 rows out of the 1,000 rows I had originally. Yeah? 303, so 1/3 of the rows have action in their genre. Yeah? Right. Head. Let's go back to head again. And now I could do that, obviously, with each and every genre. I could also check for fantasy, and that's been done here. And then I can use logical AND operations. So I could say, so basically this computes the bit list for fantasy, but now I can end the two-bit list and saying, okay, I only want to have those movies where that contain both action and fantasy. Okay, and that is what you get here. So through those bit lists, you can filter these pandas data frames easily. Yeah? So far, so good? Okay. I mean, back home, you have to go through that and really see for yourself how it works. I really invite you to go through the notebook. I still need to upload it. So, and now we will do that for all of those genres, and that's what I did here. So what I do here in this loop is, I loop over the unique genres, I sort them again, and then assign the elements in the sorted set to items in the loop. So for each item in the sorted set, I will make one iteration in the loop. And then right, so what I'm doing here is I create a new column, a new attribute in that pandas data frame. I basically just call the frame with a non-existing column. If you do that and do an assignment, that column will be created. And then assign to that column the stuff I did above. So I say, okay, whatever is contained in the genres column, if it contains this genre, that is the return value. So basically, I create, for each genre that exists in the original genre column, I will now create a new column. And you see it when you call this IMDb info information. Now I have way more columns. I have a column for each and every genre that existed before. So basically, I made the pandas data frame, the table wider. I added more columns, one bit list for each and every genre. Yeah?
Would it be easier to use a group by for this?
A group by? How do you want to group? Yeah, but what is the grouping condition?
Yeah, the list of genre. So then work there, and then after group you can use the group element.
Yeah, but you can only group if you have unique values or values you want to analyze. And I want to get to somewhere where I can say, okay, the number of action movies is 42, the number of whatever drama is 72 or something like that. That is what grouping is about. You're absolutely right. Yeah, that's a group by as in a standard database. But here, as the column contains the list, I cannot directly do a group by. So I first split it up. Yeah, see what I mean? So I will group by in a moment, or do something like a group by in a moment. Yeah. So for most of you, group by doesn't make any sense. You know it already. Yeah. So, but for the moment, I wouldn't have to add those columns. Yeah, you're right. I could run that with a query directly. That's fine. Yeah, but like that, it's easier, and the steps become clearer, I would argue. So we have these additional columns. Again, I can display the info on that. Here's the head, and now you see what has happened. Yeah, there are all these bit lists for the different genres. Okay, and now what I could do is I could count the occurrences of all movies across, of each genre across all movies. Yeah? This is called conceptually a grouping operation. Grouping and aggregation is a long story. You will learn about that in, I don't think we treat it next week, but it's in the 4th semester, big data engineering. It's a longer topic. Things can go wrong and many things to tell you about that. But basically, conceptually, what it means is for each occurrence in the original data. Yeah? So here you have a number of occurrences where, where's the action column? How I'm using musical rating? That's not shown here. Okay, but musical, for instance. Yeah. So for each of those columns, you count the number of occurrences of true. Those are the movies that are musical, obviously, and you want to count them. Yeah. So basically, what you do is you partition the data across those keywords. But in the end, you come up with something like that. Yeah? So you have romance and then the count, you have sci-fi, you have a count and count stuff like that. So this is called a grouping operation or a group by operation in databases. Typical applications are also tell me the number of women in the DSAI study program versus men versus something else. Show me how many students live in Saarbrücken versus elsewhere, stuff like that. Yeah? You build groups. Yeah? You partition your data into groups, and then for each group you compute a number. That's called group by and aggregation. Yeah? But that's something for later. I simulated here with a simple for loop. Okay, so what I'm doing here is I count the number of labels that are assigned. So we've seen that for most of the movies there are multiple labels. That's what I'm doing here. So I'm seeing in the data that there are 2,560 genres assigned. That's basically the sum over those counts here. Yeah, and then I can do an average on that. So that's 2.56 labels or genres on average for each entry. That result I could convert into a data frame again. That would look as follows. So here I create a data frame with the data here. Yeah, so basically the sorted result I get from here, and then I also give names to those columns that will be used here in the headers. I can also enforce certain types. Here I say, okay, this count attribute should have a different type. You can also put it here in this constructor if you wanted. I did it here as a separate call, and then I output it here. That's basically the result. Yeah? So that's a typical process you do in data science. You extract some data, you make tables wider, then you create new tables, condensed tables, clean tables, variations, stuff like that, and then you work your way through the notebook until eventually you get a pandas data frame where you feel like, oh yeah, I'm happy with that. I can actually do some machine learning with that. I can train a model with that. Yeah? But before you get there, you first have to do all of this stuff. Yeah? That is the problem here. Okay, so where am I? Column plus 2 setting is false. So here, okay, here it's basically here, as I created it based on this result list, and that is sorted by the genres, but of course I could also sort it on the counts. Yeah, that gives analytically, that's more interesting. Now I have a sort order descending by count, so the most important genres are listed first. Drama has the highest count, then action, comedy, adventure, thriller, and so forth. Yeah? So that's a very typical analysis you will see very often. I can do a bar plot on that. That's also very common in data science. That's stuff you see. Yeah, now you have the genre. Drama is so often, and so forth and so forth. Those distributions are also called skewed distributions. You will learn in the statistics lab or statistic class how that is defined exactly. But basically, it's always something like that. There are few entries that have a very high bar, and then it falls. It goes down very quickly. Yeah, you see these distributions very often for real data sets. So there's another fun visualization I can show you. That's called a tree plot. So basically, what this does is it creates a box, and the area of the box corresponds to the counts you find. Yeah? So drama has the highest area, then action, comedy, and so forth, and then all of that is packed into a rectangular area. Yeah? It's also kind of intuitive because because our visual system is so great in information processing. Yeah? I mean, if you think about how slow it is to just say these words I'm currently saying, and transfer information versus you show one picture, and that explains it all. Yeah? If I had to explain this visualization with text, oh, that would take a long time, blah, yeah, drama is very important. Imagine drama is very important, but then comes action, close on second place, and comedy, blah, 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 versus boom, here's a picture. Yeah? That is why data visualizations are so important in data science, but in computer science in general. And you see, that's the other message, of course, is there's a library for that. Yeah, so the artists, there's no need to implement something like that. The major challenge is to find the library and then find out how the heck do you use that library. That may also be a challenge. Yeah? But once you're done and once you used it several times, you don't have to look it up anymore when using it. Okay. Questions? So here's another example where a column is computed through a function. So I have a simple function that's basically, so a function that returns a Boolean value. So a function that returns true or false is called a predicate. Yeah? You see it here. So the input is a movie, I assume. It's not typed in this case. Yeah? So X could theoretically be anything, but I will use it such that I will only call it as a function. And then I check, not with a function, but not with a movie, but with the length of the movie. Yeah? So the length of a movie is passed into the function, and I only check whether that length is greater or equal to 122. And if that is the case, I return true, otherwise I return false. Yeah? So with that, I create a new column here, very long movie, that takes the runtime in minutes of that movie. That's another convention in Pandas you can use. You can use the dot notation to refer to columns. So that's the name of a column. And here you see, if I had a space, I couldn't use that notation because then Python would get confused if I did something like that. Invalid syntax. But if as I converted it to this underscore, I can use it like that. And then this function is applied to this very long movie function is applied to each and every value in the runtime minutes column. This will create a series, and that will then be assigned as a new column to that data frame, and it's called a very long movie. So if you go here to the right, you will see, aha, now we have those entries here again. Yeah? That's sometimes useful to condense the information or to make things crisper. Yeah? If you don't care how long a movie was, if you only want to know whether it's very long or not for your analysis, whatever the goal of your analysis is, yeah, that's typically things what you do. You want to get all the details out of the way. You want to get the high-level information you're interested in. So basically, you start with the data and then you form it step by step in a direction that allows you to do your analysis effectively, yeah? And you have a good overview on what's going on. Yeah? It's a very typical thing. Yeah? So I'm not saying you have to do it. It depends on what you want to do in your analysis. Here's the same thing, but implemented as a Lambda function. Lambda function, recall, sounds very academic, but the only thing it's doing is actually it's defining a function that doesn't have a name. Yeah? So this function has a name, and once it is defined and known to the Python interpreter, it can be called over and over again. Anyone who wants can call this function. So it's known, it's globally available, whereas this function only lives in the context of this function call, of this apply call. Yeah? It's cannot be called from anywhere else. Yeah? It's basically saying this is a parameter and this is the return value. So this is often very useful to shorten implementations and make them more readable. If you only use a function once, why not write it like that? And it does the same stuff as the thing above. So here what I'm doing is I take the revenue in millions and apply a function where it is multiplied by 1 billion, whatever that means. Doesn't make too much sense. I know the revenue, I don't know, no, that's in dollars probably, or euro. The currency is not there, yeah, but the previous entry was revenue, where's the revenue entry? It's omitted here, maybe we can go above here, we can go up here. So there's some entry revenue, and that is the revenue in millions and not in dollars directly, but here I basically converted to the dollars. Yeah, that could be something that you do. Okay. Yeah, so here's another thing that we can do. So I mentioned null values. So some of these entries may have null values, and you can check it explicitly with this isNull function. And then only those values are displayed. Yeah? So again, recall this weird expression here. What does it actually do? It creates a bit list. Yeah? This inner thing I'm highlighting here creates a bit list. So from that revenue column, yeah, create a bit list. And this is a predicate. Again, if the entry is there, there's an entry. for this particular row, it will return false because it's not null. But if there's no entry, it will return true because it is null. And so I get a bit list of length 1000. Whatever that bit list, so that bit list is then used as a parameter, again, in the square brackets on the original data frame. Then I shorten it to only display the first 3 rows from the data frame, and then I call this, use it as a parameter to display, which provides a nice formatting here in this case. Now, if you go down to the scroll to the right, you see review not a number. Yeah? So that's here the visual representation of there is nothing in that row, so it's null. You know? So that's a very important. So why would that be important in data science? A function like is null in such a data set. Why am I doing that? Well, can you imagine a situation where it would be useful to do something like that? Checking whether a particular column has entries or not. Can be this context, can be another context. So null meaning not assigned. In other words, the information is not there, it's not contained in the data. Why could that be a problem? Or where, in which situation would you, you look at a data file, or it could also be a system that keeps the data, in other words, a database, and then the system tells you, oh, for this row and this attribute value, I have no idea what the value is. I don't have that information. There's nothing assigned. Yeah.
Maybe if this row is important for your analysis, you want to clean your database and erase all these rows where this column is not given.
Yeah, okay, that's okay. Yeah. So what he's saying is, okay, we could check for those rows, and if we feel like for this attribute, we actually need information. Our analysis only works for rows where there is some information. We could modify the input data to drop the rows, to remove the rows where there is null. Then you lose information. Yeah, that's okay. That's I think we had these. I showed it on some slide. I can show it again after the break. These 3 ways of attacking these kind of problems. But first things first. My question is more like, don't think so much about the analysis. Think along the lines, you get the data from a system and you see there is some information missing. Well, what kind of situation could that be? Or what would that tell you about the original system? Maybe in the university context, university keeping track of your grades and the lectures you attended, the professors that gave those lectures, the study program assigned to you. Imagine one of those imagine you have a list of students, and for each student you have an attribute study program, and the study program for some of the students is not there, which means in the context of the data you're a student at your university, but you're not enrolled to a program. Interestingly, you're enrolled to the university, but not to the program. However, that would work, but that would be what the data would tell you. Or assume you completed a lecture, but there's no grade in the system. There's a lecture which doesn't have a professor assigned. There's a professor who doesn't have a salary assigned. Good for university, not for the professor. Yeah? There's a student who doesn't have an email address assigned. Yeah? So this is missing data, yeah? And typically this gives you a hint, this is not a problem. This may be a problem for your analysis, but it also gives you a hint, there's a problem in the system already. Yeah, you better give them a call and say, hey, I found these data items. Yeah, so basically the items I just collected is null. You could send that back to whoever keeps the data source, whoever keeps the data and say, hey, that is what I found. That is how it is supposed to be. Or is it just me, or is it a bug in your system? Okay, let's continue. So here again is a slide I showed a couple of weeks ago about cleaning data. When we talked, that was the introduction to data science slide set. And I already showed it on slide 37. So when there's a problem with the data, what do? Yeah, you have data and it has issues. So you could delete the entire item, in this case, the row belonging to a particular movie. Yeah? You find null value, however, you are interested in that particular column. Okay, then you throw that null value, the entire row away. Or the other thing is what's called impute. You replace a missing or erroneous attribute value by something that makes more sense, where you feel like you can make a wild guess that, however, allows you to keep the tuple and then do your analysis. And how that is done is used here. So here we basically fill up the values with a different value. We impute the value, and the value I use is 0. So I'm saying, okay, whenever there's a null, replace it by 0. Yeah? That's what I'm doing here. I change the original data, so I get the same here, whatever the title, Mindhorn. Does anyone know that movie? So many movies in the world. Yeah, and here we had revenue, not the number. And here the revenue is 0 million euros or dollar. I don't know. Currency is not given. I suppose it's dollars. So does anyone see a problem with that? Maybe someone else first to raise your hand. So what's the problem is what I just did. I imputed a value. I said, okay, whenever there's not a number, also not available, null, in other words, yeah, we don't have that information, I replace that missing entry, so there's nothing there, I replace it by something else. In this case, I said, okay, when there's nothing, I rather write 0. So it's not null anymore, it's 0. Null, 0. So what is the difference? And in semantics, what are the pros, what are the cons? Yeah?
Yes, if the value is unknown, then 0 is wrong. So that means it changes the mean, maybe.
Yeah, very good. Yeah, because null means unknown, 0 means it's 0 revenue. They didn't make any money with that. And now if you do any statistical analysis, for instance, the mean will change. Even though that's wrong, because the mean should not change. You don't know what the value is. Yeah, very good. And what is an advantage of doing that? Replacing, inserting the 0. I can keep the row. Yeah? I can keep maybe the row contains other information that's valuable to train my model, to do whatever I want to do with the data. Yeah?
In this case, it would seem a lot better to just insert the average value.
Yeah, very good. That would be, yes, that wouldn't, yeah.
Because now we just created a ton of blocks that might have not been
Yes.
with our average.
Exactly. For instance, you do an analysis, okay, what are the bad movies? And you define bad movies to be no revenue. No one wanted to see the movie. Then you would get all the movies where there was originally null that you then replaced by 0. Yeah? And inserting something that's statistic, some sort of average, could be the mean, could be the median, depends on your situation, would make way more sense. Very good. Okay, so what's up next? So what I'm computing here is all pairwise computations that exist in the genres. Yeah? So now we looked at individual genres. Now I want to do an analysis on the pairs of genres that exist in the data. And I do it using a recursive function. Here's an example on an output that you would get from that function. So if I call that function with a list, the list being A, B, C. So it's the same trick I'm applying as before, the input list. So I define the list by writing a string, splitting it along the comma symbol, and the result of that will be a list containing 3 characters. So I can write it down in a separate cell for you to easily understand it. That's a list, a list with 3 different values. And that list goes into this function, and this function computes all the pairs for those 3 elements that exist. So one possible pair, of course, is AB, the other is AC, the other is BC. Those are the 3 possible pairs that exist. And the longer the input list is, the more entries it has, the higher the number of those pairs. In math, this is computed by n choose k. It's basically the set of all subsets of size 2 I'm computing here for the input list. And I do that through recursion. So did you have recursion already somehow? You were in Proc 1 or? Ah, cool, okay. So basically what I do is I loop over the elements. So for a function call where there's an input list coming in, I create all the 2 set elements that contain element 0 and then the next element from that, one of the other elements from that list. So basically all combinations of element 0 with all the other elements in that list. And I append a 1. The idea of the 1 is to say there's a count. I found one occurrence of that in the input. Yeah, and if the list is greater or equal to, I call that function recursively with a shortened list. So this here means, okay, I pass as input parameter to the recursive call the list, however not starting from the 0 element, but starting from element 1. Yeah, so if that is the list, you chop off the head element and then pass whatever remains from that list, and then you recurse until eventually the recursion is terminated if it's strictly smaller 2. Yeah? So I do that with all the genres I found originally in my result data. So again, I loop over all entries in that original genre column containing those lists of genres, call this getBinary function, and produce an output that looks as follows. Yeah? So I get, for each pair occurring, I get such a tuple. So this also implies that for a movie that has a list of genres longer than 2, there will be multiple of those entries will be created, obviously. Yeah? So multiple counts will be created. Now I have that list, and I take that list to group it along those pairs of genres. So you read it here. Here you actually see the group by. So it's the same idea semantically as we had in the first part of the lecture today. Basically, I'm saying is, okay, now I have those tuples, and dear pandas, what you please do is now split this long list into groups, where the condition is as follows. Within each group, the source and the target attribute must be the same. So all of those tuples that have an adventure and mystery entry must go into the same group, into the same partition. This is also called horizontal partitioning. Basically, this number is saying, okay, the group where both the source and the target are named action has exactly 2 entries in my data. Yeah? That's called group by and aggregation. That's very confusing, the names in computer science, because it's actually the correct name would be group by and aggregation. Pandas calls it group by. Databases call it group by. Actually, it's grouping, aggregation, and projecting. Different story for semester big data engineering. Yeah? But do you get the idea, kind of, that, okay, you just count those, group them, count, yeah? So now I know which pairs occur how often in the data. And this could be displayed in what is called a pivot table. So what is a pivot table? Now I say, okay, one of the attributes of the table goes into the rows, you see it here, and one goes into the columns. And the actual count I will write in the intersection. Yeah, so this meaning if the target is comedy and the source is source. So if the source is comedy and the target is crime, there's a count of 26 entries in my database. Yeah, that's called a pivot table. Let's make the table a little wider for you to see. So why is there only zeros here? Yeah?
Because we earlier sorted them so that they only appeared in one order.
Yeah, there's only one order, and typically in those pivot elements, I mean, if I have an entry like crime family versus family crime, that would be the same information. So very often you see this mirroring effect in those kind of visualizations, depend on the attributes, but that's often what you see. Okay, so that's called, in pandas, this is called an unstack operation, and the inverse to that is a stack operation and brings you back to the original visualization. So now what you can do to visualize those things is you can change the style of each individual cell. That is this function. And what this is doing is, depending on the entry, depending on the count, it will use a different color for that particular cell. And that is done by this lambda function. So basically, it takes an input, checks that is the count, and checks whether that's greater than a certain value. If so, it uses one color. If it's smaller, it uses a different color. Yeah? And then the result is something like that. So the semantics here being, okay, if it's a relatively high value, it will be orange. If it's a medium value, it will be green. If it's 0, there's no color. This visualization is called a color map, or not a color map, a heat map. Why the heat? Because in weather and climate research, this is frequently used to visualize temperature patterns. Yeah, you have seen it probably somewhere. So if the temperature is high, it's red. If it's cold, it's blue, down to white or black even. And then those colors are projected onto a world map or something like that. Yeah, that's basically heat map, but you can do that for all kinds of data. And in this case, this is done for such a pivot table. Again, compare the two visualizations here. This is just there's a bunch of numbers that are relatively hard to process by your visual system. But when you look at that, you immediately see, oh, there's orange. Yeah? There's something, it could be red, maybe to signal some warning or alarm or a number you wouldn't expect. Yeah? Then you immediately see hotspots on such a data. So that's a very effective visualization that's widely used in data science. Yeah? And of course, you can pick the color as you want. Yeah? Only color the things that you feel like should really pop out and are important. Use any color you want, and so forth and so forth. So I did it here with a pandas data frame, a pivot table, but they are built-in visualizations that you can use. So one is in another library that's called Seaborn. That's another visualization library. And there you can directly call such a heat map with some data. Basically, what you pass here as a parameter is a so-called color palette. That's basically defining how the colors are mapped from the different values, and so forth and so forth. So this is a greenish color map. Here you also see a legend, basically explaining, okay, this color, this shade corresponds to that value, and so forth and so forth. So one thing you could do is you throw away the numbers. That's also done very often. Yeah? If you only want to see where the hotspots are, and that's another visualization. Yeah? Depending on what you want, but you can do it in many ways. Yeah? Heat map, very important. Okay. So what else do I have? So here's another example where look at the movies directors. So here again, that is this dot syntax. Director as an attribute name, yeah? The name of one of the columns. I can use it with a dot syntax. I do a value count. So that's basically, again, a grouping operation, meaning Ridley Scott appears 8 times in that data, David Yates 6 times, and so forth and so forth. So, what's the difference here? Same as above. Was this intended? Oh, that's a command to do. Oh, no, that's redundant. That's left over. We don't need that. Yeah, but here's just one other visualization I wanted to show you. So that's a pie plot. You've seen that in Excel. The interesting thing about this variant is that you increase the distance of the piece from its center depending on a parameter. Yeah, so that is this explode function here. And basically I computed here taking the value counts and then adjusting it by some numbers, and like that you can say, okay, the higher the value, the more the thing pops out, not color-wise, but as a distance from the center of that pie. That's another visualization you could use there. So as I showed you already when talking about the data science, when I presented this data science slide set, Introduction to Data Science, there are tons of visualizations that are possible. I just highlighted some of them.